Hello all, welcome to another session of JavaScript. So let's start our session. Let me share my screen. Right. So let's have a quick recap of what are the things that we have learned in the previous session. So in the previous session, we have clearly observed that what is meant by OOPs, why do we require an object-oriented programming style of programming. We have seen the fundamental point of classes, why the classes and how we can use the classes and sort of a thing. So in today's session, let's try to understand inheritance in static properties and methods. And also let's try to understand private, it is public, private, protected methods or properties. We can do it this thing, the visibility. Let's try to understand these three important things that are present in the OOPs. Once you get a good grasp on these respective things, then we are done with the concept of OOPs altogether. So without any further delay, let's go ahead. Let me create a file. I'll say oop2.js. Sorry. Coming to the first topic, which is actually known as inheritance. Inheritance. So as you know, inheritance means getting um, properties from ancestors. For example, to be understanding about this inheritance, let's say we have this one very important thing. Let's take a family. Whatever grandfather, grandmother earns, that will be inherited to their kids. Similarly, whatever the parents will earn, those will be inherited to their children. So this is kind of a inheritance that is generally that we observe in our real life. Now the same kind of inheritance is actually being applied between classes too. So here the inheritance topics, what are things that we are observing in the real life where grandfathers will, properties will be inherited by the, parents, which is nothing but properties are nothing but money, gold, and etc. All kind of things. So that same kind of inheritance is actually being implemented in the JavaScript, specifically in object-oriented program, that too on the classes part. So now let's try to understand what is meant by this inheritance. If you already know what is meant by inheritance, let's try to understand how does this given particular inheritance is actually being implemented with the respect to of objects, with the respect to of objects altogether. So in that situation, let me do it. Let me say it work. Um, you can say class inheritance. Class inheritance is a way for one class, not once, one class extends another class. So we can create new functionality on top of existing. So the concept of this entire thing of inheritance has been adapted into the object-oriented programming style, because in general life we can clearly see grandfathers might build a two-storied building, but if that being inherited to the parents, if the parents are uh, you know working hard enough, smart enough, they'll make the two-story building into 10-story building altogether, right? So inheritance, or the underlying thing about this given particular inheritance, is the underlying principle, even though you'll see in a real life or you'll see in any given particular case, the underlying format is this inheritance that we are actually observing. Once it is received from parents, the current generation will try to make some improvements to it and will pass on to next generation. The same thing is happening here. Let's say if you have created one single class, so at some point of time you want to advance this one single class. So that's what, where instead of re-updating the same class, we'll create a new class, and whatever previous class that we have, that will inherit all of its properties and methods to the newly created children class. And in the newly children created class, we will make our advancements. That's how this inheritance works in this format of this class. So that's where we can create a new functionality on top of the existing ones. So to deal with this given particular inheritance in classes, we need to understand this one given particular keyword known as extents. We need to understand this one given particular thing known as an extents. So if you want me to be this, let me do this. Let's say we have a class animal. Sorry, class animal. not Ranbir Singh animal, but it's just a class animal. Now, one very important thing we need to understand is every animal will be having a name. Let's say we can call lions, we can call tigers, we can call monkeys. All of them are having some kind of a collective name. So I can say I can create a constructor where all animal will have a common name. All animal will have any kind of a name, any kind of a name. Now, apart from this given particular thing, I just also want to mention this one very important thing. What are the actions that can be performed by animals which had a yardstick, which had a yardstick to measure? For example, we can say speed. Speed is one such kind of a thing. So speed means animal should run. So animal can perform an action known as run. So I can create a run method. Always remember, when you are naming the properties, when you are naming the properties specifically, make sure what does this class is for. Animal will have name. Animal can run. And also, what are the other things that animal can do? It can stop. It can stop. Let's take a simple example. Do not go a deeper example. Animal from running, it can come to stop position. From stop position, it can go and run and hunt the things. So animal can perform these two verbs. So that's why always remember, when naming the respective methods, name should be in the form of verb. Okay. Now coming back to this given particular thing, I'll fill this function. This dot speed is actually equal to, initially it should be the value of 0. I'll say this dot name is equal to name. Initially, for every animal, I want the speed property should be 0. Now, the speed, I'll pass the value speed, this value speed, into run method, and I'll say this dot speed is something known as speed. Whatever value that we pass, that should be the new value of speed property. And I'll say console dot log. I'll mention this thing. This dot name runs with a speed underscore this dot speed runs. Similarly, stop. So whenever this thing happens, stop happens, speed value will become 0, because that's how we can implement a real world thing. Whenever an animal stops running, its speed will automatically become 0. So I'll simply say console.log. I'll say this dot name stands still. So we have, this is our class. This is our class. Now let's create an object from this given particular class. Let's say let animal is equal to, I'll simply say new animal, and I'll simply mention lion. I'll mention lion. Now if I run the sorry, node oop2.js, sorry, this is oop2.js, right? Okay, I haven't mentioned console log, my bad. So what exactly object has been created, what are its properties, and is being stored inside this variable, or is being referred into this respective variable animal. You can clearly see that this variable is referring to an object where its property speed is initially equal to the value of 0, and we have this property name lion. So whatever data that we have passed, it has taken up by this constructor function and is presented here. And so the name property is whatever value that we pass to the constructor function. Now it's completely fine. Now what I do is I'll say animal dot run. So for this given particular class, we have constructor and we also have two methods, run and stop. So if you want to call run, we need to pass some speed. So I'll say I'll send something like 50. And now if I execute it, you can clearly see it is telling that lion runs with the speed 50. Or let me be more clear. 50 km page. 50 km page. right? If you can rerun the code, you can clearly see this is getting us the value as speed to the value of 50. If you can clearly observe, if I execute this method, whatever speed value initially is 0 will be value of 50, because for run while running run method, I need to send some number which will be stored here in the speed, and that will be value here. So this would be something like this. This dot speed would be something like 50, because we are sending the data of 50. We are sending the data of 50 to this, and this is being actually stored inside this respective thing. This is how this entire thing is actually working, right? And we can clearly see this. Again, if I, after this thing, if I have this animal, now I can clearly see after this code, this method has been run, my speed value is 50. Initially, while creating the object, speed property has the value of 0. But once I execute this property and send some speed, then automatically my object got updated, because in the first step I'm doing, I'm updating this dot speed, which is what I'm updating speed property. That's why you can clearly see it is visible here. It is visible here. And even if you say animal dot stop, yes, I can clearly see it is telling that first animal is running at 50 kmph, then second, let me give it like this. Then second, animal already stopped. So that's why we have this output known as lion stands still. Lion stands still. Lion stands still. So this is a basic general class that I have taken, to explain you how this entire class will be working. How this class will be working, how when we create an object and we try to manipulate, work with this respect to object altogether. How does this entire thing happen? That's what I have explained till this given particular point. So now the thing is if you can clearly observe, let's say, let's keep all of these things into commented part. We have this one single class. Now let me create another class. Let us create rabbit, for example, because rabbit is also an animal. Rabbit is also an animal. Rabbit is also an animal. So while creating this rabbit class, I can simply say the constructor to be something like name, and we have this thing known as this dot name is equal to name. And what are the operations that can be done by the rabbit? RABB8. It can do these two things. So it can do these two things. So I'll copy paste, and also I'll keep this thing, this dot speed initially should be 0. Initially should be 0. So rabbit can run, rabbit can stop. These are the two things that it can be done. But if you can clearly observe, here we have already written a code for animal. Like animal have these basic things. Animal have this basic name. Animal have this basic speed. Animal can perform these two operations, run and stop. So we have already written. Now, if you can clearly observe, even this class rabbit, even this rabbit can perform all the operations, Now, instead of copy pasting it, because the same code that you are seeing is actually copy pasted from here. So instead of doing all of these things, why can't we keep this entire animal class as a parent class for our rabbit, so that once we keep this animal class as our parent of this rabbit class, according to this class inheritance, the definition tells that one class extends another class, which is nothing but we can extend what are the things that are present inside this animal class. We have this constructor, we have these three important things. We have two methods and this constructor. Instead of copying them again here, let me say, copying them again here. What if we extend this given particular animal class as a parent to this rabbit class? That is what meant by inheritance. So that what happens is, like, whatever things that are present inside the animal class, without them here being copy pasted, we can use it in rabbit class. That's what meant by inheritance. So all these constructors and all these methods for a given class will be sent to its children class, will be sent to in children class if this class and this class participate in inheritance, because that's what this state tells us. One class extends another's. So I want this animal class to extend this rabbit class, which is nothing but I want this animal class to be parent of this given particular rabbit class. So how can I do that? So we have this given particular keyword known as extends. We have this keyword known as extends, and we need to clearly tell this rabbit class should extend which one? This rabbit class should extend animal class. This rabbit class should extend animal class. So with this one single statement, rabbit class rabbit extends animal. Now whatever objects that will be created using rabbit class will also have properties like name, speed, properties like name and speed. We'll also have methods run and stop. Run and stop. So for example, I have written the code and there is nothing like code. I have not written any kind of a code inside rabbit class. If I'll say let rabbit is equal to new rabbit, I'll say something like white rabbit. One very important thing we need to understand is under rabbit class, I haven't written a single line of code. But as we know that this rabbit class will be children class for animal, because that's what this statement means. This rabbit class becomes children to this animal class. So once a class becomes children to this another class, then this parent class, whatever things like whatever constructors the parent class has, what are the methods that parent class has, will also be accessed by rabbit class, will also be accessed by rabbit class, will also be accessed by rabbit class. So whenever I want to create any kind of a object from this rabbit class, even if it doesn't have code, if it's participating in inheritance, any kind of an inheritance here, then whatever things that are in parent class, I should be dealing with the parent class logic. I should be dealing with the parent class logic. So inside the parent class logic, I need to send a name as a property. I need to send a name. You can clearly see even here, we have did the same. When creating an object, we have said new animal and we have said some kind of a name. So that's the same kind of thing that you have to do. That's the same kind of thing. So now here, creating an object from the rabbit class, to be more precise, from the rabbit class using inheritance. One another important thing I want to mention is when you are dealing with the inheritance, the children class need not to have this entire code, because due to inheritance, whatever things that are present in the parent class will be acquired by these children, that is what meant by inheritance. Whatever the things that are owned by the parents, will be owned by children. So that's why you can clearly say, so even I can say this rabbit dot run and I can send speed. If I say rabbit dot run, you can clearly observe this run will be executed. Even if you have this, we have created this rabbit thing, right? Let's see what is the output. What object is stored inside this rabbit thing? Console.log rabbit. You'll see that this object is created from a class known as rabbit. But technically speaking, this object is utilizing the entire data that is present in parent class. But in the output, it is clearly mentioning that this rabbit object is being created from this class. Even though this class having inheritance with this animal, but still, whenever we have this new rabbit, whatever things that we have mentioned here, after the new operator, this will be the parent, or from this, we can say this object is generated. From this class, we can clearly say this object is generated. That's how this entire thing actually works. And you can clearly see the properties. Speed is 0 and name is white rabbit. If you can clearly remember, inside rabbit class, we don't have code. But this speed property and name property, both are present in the parent constructor code. This is the advantage of inheritance. I can run, sorry, let's say for example, here we have this run and stop. I can execute here. I'll simply say like this, and I'll say rabbit dot stop. So that's the advantage of inheritance. We can access the properties, we can access the methods from the parent class altogether, and we can access them using our objects. The objects can be created from children class. The object can be created from children class, but still we can access parent properties and parent methods. Parent methods. That's how about this given particular inheritance topic. Now, one important thing I need to mention is let me show it to you. You see it? This run and stop are both are getting executed. White rabbit run with the speed of 40 kmph. White rabbit stand still. And still. Right? This is how this entire thing actually work. The entire inheritance actually work. Similarly, I can if I want to write what is the unique thing that rabbit can does? What is the unique thing that rabbit can does? It can hide well. It can hide well. So I'll simply say dot log this dot name. Sorry, heights. This dot name heights. What are things that we have that can be hidden? That can be hidden. So you can say rabbit dot hide. We have this rabbit dot hide where it says white rabbit hides. White rabbit hides. So this is how we can do that. So we can have in children class we can have its own methods. We can have its own methods, but it can get the constructor. It gets the run and stop from the parent class. That's what meant by this respective thing known as an inheritance thing. Now let's go ahead and understand the nitty-gritties of it. Let me keep this thing as like this. For example, if I say, let me write a multi-line comment. So I should definitely write that object of rabbit class, specifically object of rabbit class have access to both rabbit methods, which is hide, and also to animal methods, which are run and soft. Run and soft altogether. So one very important thing we need to understand is whenever we are dealing with this respective format of instructors or in this format of this inheritance, the constructors and sort of a thing, at some point of times we can actually override the constructor. For example, here rabbit class doesn't have any kind of an what I can say, any kind of a constructor altogether. So if I want to create a new constructor, I have a method to use it. I have a method to use it. But similarly, if I want to override any of these methods, to override any of the methods, let's say for example, according to the inheritance, the stop method would be saying making the speed value as equal to the value of 0. Speed value will be actually equal to the value of 0, and it says this animal stands still. But if I want to override the same method in my children class, I can do that. I can do that. That comes under the point of overriding a method. Now let's move forward and let's try to override a method. By default, all methods I can say that are specified, or I can say instead of telling that thing, or I can say, yep. By default, all methods that are not specified in this respective class rabbit, which are not specified in this class rabbit, are actually taken from class animal, which is nothing but parent class, which is nothing but this run and stop are not at all classified inside the class rabbit, but they are taken from the parent class named animal. Parent class named animal. But if we specify our own method in a rabbit, if we specify our own method in rabbit, we have hide. If I say I have stop, if I have stop. Similarly, if you can clearly observe, there is a stop method in parent class also. But we want our own stop method for rabbit class. So how can we do it? So this comes under overriding the method, which is nothing but already in parent class, we have a method named as stop. Parent class, we have a method named as stop. Now here we have to understand this one very important thing. that whenever we have this thing known as in stop, whenever we want to override anything from the parent, from the parent, usually the standard thing that in general anyone a good practice that when writing this or when working with this given particular object oriented programming is that usually, however, we don't want totally to replace, let's say in this entire stop method, we have two important things. If sometimes in sometimes what is whenever I'm overriding a given particular parent class, parent method or method in parent class altogether, in such scenarios, in specifically in that scenarios altogether, we don't totally replace parent method, but rather we want to build on top of it, which is we want to tweak this thing. This is, let's say this is version v1, we want to make this given particular overriding method as version 2, we want to tweak it or we want to extend its functionality. We do something in our method, but we call the parent method before or after it. We do something in this method, we try to add some functionality, different functionality, or we try to extend the functionality of the parent method, and we call this parent method or the method the stop, which is in the present in the parent class, which is known as parent method, before or after it or during the process to implement all of these things. Let me say, let me write it. We have a keyword known as super. We have a super keyword. So the keyword itself is named as super. Keyword itself is named as super. Super is a keyword for that. So we can use this super as this super dot method. So this helps us, this super dot method helps us to call a parent method. Similarly, if I have this thing only super and inside I have mentioned few things. Now this is used to call a parent constructor inside our constructor, or instead of inside children constructor. Okay. To be more precise, this is only inside our children constructor or any children constructor at that given point of time. At that given point of time. Now let's try to mm, do that given particular. Let's try to use this given particular thing. So for that, let me say here, I'll be going back to this given particular thing. Now I want to say, I want to execute this stop, but don't want to override this parent method. This is the parent method. I don't want to completely change this. I will use this stop method, but apart from that, I'll add my own. So first things first, I need to access that stop method. I need to access this stop method, which is present in my parent class first. So for that, I'll be doing super dot, I think super dot stop. We have this method because if you can clearly observe, we have the super key, and after super, we have this method name, and we need to call this thing. That's what I have did. That's what I have did. So here, what we are actually doing, calling parent stop method. That's what we are actually doing it. That's what we are actually doing it. And on top of it, I'll just say this dot hide off, which is nothing but whenever a rabbit stops, it hides. That's what I just want to add. That's what I just want to add. That's what I just want to say. Why I have written this given particular, I have added some extra functionality, suggesting that when a rabbit stops, okay, rabbit stops, then it hides. So if you can clearly remember, stop is a verb, hide is a verb. For hide, we have a method. For stop, we also have this method from the parent. From the parent, we also have this method. So I'm using the same thing. So in rabbit class specifically, whenever we create any kind of an object from this rabbit class, if I try to execute this stop, first we call, or this given particular parent stop method will be called, and this additional functionality that we have included, that also will be called. So I'll say rabbit run, rabbit stop instead of rabbit hide. I'll simply do this. Let me say code oop 2 dot js thing altogether. So in that thing, okay, sorry, not code, it's a node oop 2 dot js. Now if you can clearly observe, we have this rabbit. Okay, let's remove this thing. We have this thing like this. Right now, look, if we see this given respect to output, let me hover it up. Let me hover it up. And we can clearly, sorry, we can clearly see that whenever this run is executing from the parent class, that's why we get white rabbits run with a speed of 40 kmph. That's completely fine. But whenever we hit this stop, here we are executing this method. We are executing this method, not the parent method. We're executing this method in which, in this method, we are calling our parent method and we are also implementing the hide function. That's why you can clearly see white rabbit stands still, white rabbit hides, white rabbit hides. So this is how this given particular thing actually work. This is how this given particular thing actually work. Sorry. So in this case, whenever we call stop method in the parent in a children class, this parent method will be called during the process. Will This parent method will be called during process. And another important thing I want to mention is whenever we have this stop method, specifically this entire stop method. Sorry, specifically we have this entire stop method where at this given point of time, this method cannot be written inside, or it can be written in, like, methods in classes can be written inside um what you can say, inside an arrow functions, or can be written in arrow functions altogether. But we also want to understand this one very important: super keyword doesn't work properly, or doesn't work inside arrow function. Whenever you are planning to use this super keyword, don't write this method in arrow functions format. Don't write this method in the format of arrow functions. Don't write this function in the format of arrow functions. So arrow functions doesn't have super keyword. Arrow functions doesn't have super keyword. This is a normal function declaration. So inside that we have super. I think instead with that we have this super keyword altogether. That's completely working. But whenever you write the same method in arrow functions format, if in that arrow function we have super dot stop or super dot something, it doesn't work. It doesn't work altogether. So this is what meant by overriding a respective method. Now let's try to understand. We also have this other use case of super where if you want to call a parent constructor inside the children constructor, which is nothing but, if I say overriding constructor, as I have mentioned, this one very important thing, which is nothing but here we have overridden our parent method. But what if even though our parent class has some kind of a constructor where what object that is being created in children class, it will have the constructors from the parent class, it will have properties from the parent class. What if we want to override the constructor? What if we want to override the constructor in the children class? What if we want to override the constructor in the children class? So with constructors, it will get a little bit tricky. So you must be very much focused to understand this given particular how we can actually override the constructors altogether. So coming back to this given particular session, where we have with constructors, it gets a little bit trickier part. Until now, until this given particular point, our rabbit class doesn't have a constructor function. So all the constructor function is dependent on parent class. So according to the specification, currently we are using ES6 plus, where if you can clearly observe in this specification, let me write it. It's a very important thing. Sorry, if a class, if a class extends another class and has no constructor, then in that children class, in that children class, uh, empty constructor, empty constructor is generated. Empty constructor is actually generated. So for example, if you want me to give a simple example, let's say it would be in this format. Right. So that would look like this. you want that thing, it would be, I take this as an example. Let me say it like this. So I'll say class rabbit extends animal, where instead of it we have this constructor. We have this constructor, like it will have some kind of an arguments or parameters, and which will have sorry, yes, yeah, yes. So this is the kind of code that will be created here inside our children class, because it doesn't have any kind of a constructor function. So this empty constructor function is already created inside this rabbit class, because it doesn't have any kind of a constructor function defined in it. It doesn't have any kind of a, sorry, it doesn't have any kind of a constructor function defined inside it. That's why this empty thing, this a basic empty thing that will be, you know, implemented. So instead it will be saying like this. Here we have name. So here we have arcs, right? This, not this, arcs, right? This would be the same. So instead it would be triple dot. If you can clearly remember, this is rest symbol, the rest symbol that we have seen, right? That's that same kind of a symbol that we are actually doing it here. Now, if you can clearly go to your parent class and see the constructor function, it has speed property and it has a name property altogether. That's how this entire thing is exactly present. Now, if you want to override the parent one, if you want to override the parent constructors in your children constructors, we have this thing. We have this thing. Super off. Super off. So what I would like to do is, every rabbit has its name. Every rabbit has its speed. Every rabbit it has ear length, because for rabbits, I still can remember a long ears. So different breed of rabbits have different ear length. So I'll write a constructor function based upon that. I'll say name and ear length. So every constructor function will have, sorry, this every rabbit will have its own name and its ear length. I'll say this dot name is equal to name. This dot ear length is equal to ear length. And another important thing I want to mention is this dot speed is equal to 0. This dot speed is actually equal to the value of 0. Now, so here if you can clearly observe, we have added our custom constructor function. So this custom constructor function will specify this ear length as a new property, compared to this parent constructor function. In parent constructor function, we have speed and name properties. That's completely fine. But here, the custom constructor function present in children class will only have this ear length as an addition to the parent ones. Addition to the parent ones. Now, still, if you try to read it, let's say if I have to pass a name and I have to pass ear length. That's what we are doing. Name and ear length are the two important parameters that is being expected by this respective constructor altogether. So in this scenario, whenever I pass name and the ear length, if I try to run the code, you'll see an error. Must call super constructor in the derived class before accessing this, or before returning from derived constructor. So whenever you try to add some kind of your own additions and mention the parents properties like this, it doesn't work in this format. Why? Because constructors in the inheriting class must call with this one single thing. Must call with this. Where is this comment? This. Must call this with this single important thing. So if I want to actually deal with this given particular error, if I want to deal with it, I should be simply dealing with this thing. So I'll say name is the constructor, or name is the property which is also present in the parent class, which is also present in the class. So instead of name, I'll say super of name. I'll say super of name. I'll say super of name. And this ear length is equal to ear length, and the speed, it's not that worried. It's not need to be worried. Super of name. So here we, oh sorry, let me write it in a comment. So here we are accessing this name property from the parent class constructor. Parent class constructor. Now if I run the code, it's completely fine. Instead of these things, let me write it. Console dot log. Console dot log. I'll say rabbit. Now you can see we have speed, name, and year length. These are three important things that exactly present here. So this is how this entire things. And coming back to this given particular thing, if you want to override class fields, this would be a bit trickier. We can override not only methods, we can also override our constructors, we can also override our class fields. Although there is a tricky behavior when we access overridden field in the parent constructor, which is a unique thing, For example, in the name, let's say here we have a constructor known as mm, name color is equal to black. Here, this is a class field. This is a class field. Specifically, this is a class field. Now, for this given particular thing, for this given particular rabbit, a new object that is created from your children class, where it has properties of name, it has properties of year length, and color and speed. All will be present. So, four properties will be present for an object that is being created using rabbit class, which is nothing but children's class. You can clearly see those four colors, those four colors. Now comes to this important thing. If you ever want to manipulate this thing, if you ever want to manipulate or trick, I think this would be a trickier thing. Um, so here we are actually investing this consistent. Mm, so if I want to do it, it does do it. Um, let's take this given particular thing in the advanced part, because somehow I need to tell an example where that creates a very confusion when dealing with the super internals of home object that would eventually is not necessary for your this place. But at this point of time, understanding about this one single thing, like overriding the constructors, overriding these respective methods, would be sufficient. Overriding these fields is bit trickier, because I need to teach you about super internals, which is super advanced compared to other topics that we have seen till this far. But anyways, we'll cover this part at some other point in this respective sessions. So this is all about the inheritance topic that we want to learn in our oops concept, in our oops, the classes, the objects in our given particular things. So that's it for this respective session, and we will see the remaining parts, because if we try to understand the static properties and methods and this public private property protected things, this we will teach. We can go ahead with next class altogether. But here we have understood about the inheritance and the different things altogether in our today's sessions altogether. So we'll deal the other parts in the next session, and we'll see how this entire thing goes up. So that's all for this session. Thank you all.